Hello everyone, today I'll just be making a short video about Cassini and its impending end of mission. Now unfortunately right now I can't really make a long complete video about all around Cassini's mission, and I don't have to either. I'll just give two little recommendations and go into a bit more detail about two little facts about Cassini that I think are quite interesting. So I'll leave out a lot of really important stuff. Now the first recommendation of course is that Scott Manley has already made a really great video about Cassini's overall mission, and I will link this in the description, and it already summarizes Cassini's overall mission really well. And my second quick recommendation is that you check out not only NASA's website where they have lots of articles about Cassini, but also their Eyes on the Solar System app and their update on this, the Eyes on Cassini program, where you can get live replay and also scheduled future visualizations of Cassini's mission, all of Cassini's mission, and of course Cassini's finale and entry into Saturn's atmosphere. Now there's two rather interesting subtopics about Cassini that I would like to talk about that I haven't seen much about yet. So one of them is the actual orbital mechanics and maneuvering of Cassini. Cassini is a relatively old-fashioned spacecraft. Like every space probe that is further out, it had a very long journey, and thus the spacecraft's actual development and build is of course relatively old-fashioned. It's relatively heavy, and it doesn't have that much delta V. We all know that it needed gravity assists to get to Saturn in the first place, but once at Saturn it did two interesting tricks really to maneuver with very little delta V. One was of course to stay in a very elliptical orbit with a very high apoapsis, which means that the speed at apoapsis is very low, which means that you can have a relatively large impact on your trajectory while only using very little delta V, and thus relatively easily maneuver around Saturn with very little delta V. But the other important trick was to use Titan, Saturn's heaviest moon, for frequent gravity assists, which was actually kind of tricky because it meant that with every Titan flyby they already had to plan for the next Titan flyby and do so reliably every single time. They did have enough delta V to affect the trajectory. Once at apoapsis they were slow enough to significantly affect their trajectory all the way down to the periapsis, and thus once they were on a Titan encounter trajectory they could make adjustments to manipulate how exactly that Titan encounter would change their orbital parameters. But in order to get to that Titan encounter trajectory, they had to plan this during the last Titan encounter, so that during every Titan encounter they had to schedule it so that the trajectory after that Titan encounter would already bring them back to the next Titan encounter soon enough, because otherwise they would essentially lose that means of maneuvering, and without a Titan encounter they had very little ways to really strongly influence their trajectory, and thus they would have a hard time ever getting back to a Titan encounter if they hadn't planned ahead very carefully. So Cassini was definitely one of those spacecraft where even after reaching the destination it wouldn't just be in a safe and comfortable parking orbit around its destination, but actually had to do precise maneuvers just to stay in control and stay at its target orbit for a prolonged time, and it did so for a very long time. Scott Manley started his video with a few facts about 1997 to give an idea of how long ago that is. To me, that's just Cassini was launched about 1 year after I was born. When it arrived at Saturn, I was around 8, so I can't really get an idea as to how long it has been up there. To me, it's just been Cassini has basically been at Saturn as long as I can think back, and that's quite a while. And it was basically a constant row of precision maneuvers just to keep Cassini in this controllable orbit for all that time. And in fact, Cassini's last Titan flyby was just about one orbit ago now, and that actually did most of the work to push Cassini's periapsis into Saturn's atmosphere. Then another thing I would like to talk about is some of the science Cassini did. Now, you may already know that the Huygens lander, which was the first lander on any body in the outer solar system, was developed by the European Space Agency, but actually one of the instruments right on the Cassini probe itself was developed at the IRS at University Stuttgart and also partially operated from there. That was the CDA, the Cosmic Dust Analyzer, which analyzed cosmic dust, especially dust from the rings of Saturn, which are actually much more than just the ones you can see in the images you commonly see of Saturn, but if you look extremely closely with proper telescopes and analyze those pictures, you can see much thinner and dimmer rings that stretch much further out from Saturn itself. And these rings could be very closely sampled, and the particles in them, the dust around them, could be analyzed in its density, in its trajectory, and its properties. And this, together with other instruments on Cassini, told us things about Saturn and its rings that are not just astronomy, but to some degree actually fundamental physics. Like the rings of Saturn behave partially viscous. They are not only dominated by gravitational forces and orbital mechanics, but the collisions happening in some of those rings, at least, of course it's different from ring to ring because they're made up of different amounts of different sized bodies, but in some of those rings the collisions between the particles actually influence the behavior of the overall ring to a similar degree as gravity does. And while orbital mechanics are relatively well understood, the viscous behavior of those rings actually helped verify a lot of computational models and theories. Also, examining the rings and the dust around them does not only tell us about the rings themselves, but also about Saturn's magnetic field and thus also about Saturn's deeper core. Of course, Cassini has done a lot more than just researched Saturn's rings. It has also researched its atmosphere and its moons. It has delivered some data hinting towards at least the possibility of some of Saturn's moons being hospitable to some potential forms of life. And of course, one of the reasons why Cassini is now being plunged into Saturn's atmosphere is in order not to contaminate any of the Saturnian system or the Saturn moons, because we suspect that there might be at least some traces of basic enzymes or microbial life on those moons, and it would be very hindering in researching these further in the future. And of course, there's also a sort of moral question in case we contaminate these moons. And back when Cassini was built and launched, it was not properly sterilized. Now, the actual question as to how terrible it would actually be to contaminate one of those moons is quite arguable, but either way, Cassini has reached the end of its mission. It is out of fuel, it is no longer capable of further extending its mission, and thus ending the mission this way is quite understandable for an extra bit of caution also for delivering data from very close to Saturn, rather than just keeping on the same orbit for a few more days and then eventually losing signal anyways. Either way, it is sad to see Cassini go, and we will remember the Cassini-Huygens mission as a great contribution to science. But eventually, any space probe or satellite reaches a end of life, and quite commonly, as in the Cassini mission, long after the primary mission already ended. With that, I will end this video. A live stream of the actual end of mission should have already started. And as always, thanks for watching.